So this is going to be the application which we are going to build in today's video. We are going to fetch some news from the server. If there is no news, we are going to show this state that as of now there are no news. But let's say we checked after some time, we again made one request to the network, and if there are proper news articles available, we are going to show news in this form. Every news article will be shown on full screen, and like many popular social media apps, if we scroll up, we are going to see the next news. Okay, we can also scroll back, we can check multiple news like this, and this is going to be our news application. And inside this application we have implemented so many things. We have implemented UI layer, we have implemented data layer, we have implemented dependency injection as well. We have implemented all of the things with Retrofit, Coroutines Flow, and data source implementation, Dagger HILT, and MVVM approach, all of those things. And this is a fully functional Android application. It follows best practices, and this is built purely in Jetpack Compose. So let's start today's video where we are going to implement this. Please watch this video completely and please share your feedback, please share your thoughts in the comment section, and please hit the subscribe button. Let's start coding. Let's create a new project. We are going to select this empty activity. We are going to call it news in short. This is going to be our package, and we are going to go ahead, and our project is getting created. Let's remove these things. We will code everything from scratch. Now the next thing is, let's go to our build.gradle. Let's use 34 as the compile SDK API. Okay, let's modify these Java versions also. Let's use 17 in both of these places, and here also we are going to use 17. Let's use target SDK also 34, and now we can finally sync the project. The next thing is, as I mentioned, that we are trying to create more than one module in this application development video. We are going to utilize some of these dependency in second module as well, right? Let's say we create a module for internet related things. When we try to make our API calls, we will try to just check the internet status. We will try to show some kind of error or alerts if internet is not present, right? So these internet related thing we will put in a separate module. We'll call it, let's say, utilities module, and some of these dependencies will be utilized there as well. So instead of writing these dependencies duplicately in both of these modules, we can utilize central dependency management system. And if we are trying to develop modular Android application, we need to make sure we are using some kind of technique to achieve central dependency management. Okay, we can put some kind of dependency in a place, and we can utilize from that central place in every module. There are two common ways. Either we can use version catalog. This is in a early stage. We can also use build src directory for our central dependency management system, which is a proven technique. We are going to utilize the same in this video. So let's start. And to create build src module, let's first choose project window template, and we need to select here, we need to click on this directory, and we will just name it as build src. Okay, and let's click on enter. So our directory will be created. Inside this, the first step is, let's create a file and let's name it build.gradle.kts. Then inside this build.gradle.kts file, first step is we need to import the Kotlin DSL plugin. We can import that from Kotlin DSL, and the plugin name is Kotlin DSL, this one. Okay, and we need to use this inside the plugin blog. We need to just write Kotlin DSL, this plugin we need. We need to also use the repositories blog, and we need to write Maven Central. Okay, then we can just sync the project, and then our Gradle and build folder will be generated. Now the next step is we need to define these dependency inside our build src module. Okay, how we can do that? First of all, let's select this, and let's create one directory. Okay, and we are going to take source/main/java. Now inside this Java folder we can create one class, or let's say one singleton class. We can use object and we can call it dependencies. Okay, and we can create one another class for the respective versions, so we can call it versions. Let's select the object class itself. Okay, inside dependency we need to define the dependency part, and inside version we need to define the respective version. So if you are not familiar, every dependency has the dependency part before this colon, and after colon it has the respective version. So let's say if I tell you we need to define this inside our build src module. So let's take this dependency, come here, paste it, comment this. Now you can define a name for this dependency. So let's say core ktx by lazy. We are going to use lazy initialization, and we can define the dependency part of it. So we need to just take what we have before this colon. Now after the colon we can just take this part, we can come to versions, we can define here one version, core ktx. Okay, and we can just use the version whatever we have. Okay, this way we can break down this dependency core ktx into two part, one for dependency part, and then the respective versions we can define here. We can also make it const, because this is not going to change anytime soon in the project, and this is going to be a constant itself. Alright, now with the help of these two things, what we can do here is we can remove this. We can take dependencies dot core ktx, okay, which we have defined inside our dependencies file. Now this dependency need a version, so we can just use with the help of $symbol versions dot core ktx. This way we can break down all the dependencies into these two files, dependencies and versions. Similarly, I have defined all of these dependency we were using inside our build.gradle kts inside app module. We have the versions as well, we have the dependencies as well. Now we can utilize these inside our build.gradle. So we can remove these and we can access from our build src directory. We can just sync the project. Now our project is ready, and this is the first step in order to achieve modularity inside any project. If you are going to build a modular application, you need to build multiple modules, and those modules will be needing the dependency. And if you have all the dependencies in a central place, which is our build src, so we can just access the dependency from this module. Okay, let me show you this. So let's say we have one another module coming up, and that is going to be Android library. Let's call it utilities, and let's click on finish. So one new module will be created, and inside this module we are going to put which we are going to use inside our project. Okay, so this utility also has a build.gradle kts file, and if you see, this is also having some kind of dependencies, right? It has the ktx dependency. So what we are going to do, we will use from our dependencies dot core ktx. Okay, we no need to define here. And you know what is the main advantage of doing that? One, of course, the modular approach. Another thing is, let's say multiple developers are working in a team, they are working on different modules. So some developer, they were working on this utility module and they started using here some different version, and some other developer who were working in app module, they were also having the normal static dependency with some different version, right? So let's say here 1.9.0 were there, and somehow someone were using 2.3.0 or something else, right? So these two dependency will be having two different version inside the same project. That should not be the case. It can lead to some unwanted issues. Okay, that's why this central dependency management is the key to go. And now inside our utilities we are using from build src, we can remove this. Now the next thing is this app compact and material dependency. So do we have? Yes, we have this app compact and material. So we just need to access from there. Okay, like this material. We can remove these, and few other thing we are going to use Java 17. We need to change here as well, inside this also, and we are going to use 34 as the compile SDK. Now we can sync the project, and now our project has one new module called utility. If you just go to the setting files, you will see we have these two module, app and utilities. And if some of you are wondering that why don't this build src is mentioned inside settings.gradle, that's because this is a normal directory. So now the next thing is we need to use this utility module inside our app module, right? So we need to do one thing. We will go inside the dependency. We will define one object class. We will call it modules. We are going to define here the new modules which we have created, right? We can just take this path. First, let's take this module name, utilities. Let's define it with one constant name, utilities, and we need to define the path. Basically, we need this module path, okay? And we can define it here. Now we can close everything. Now, if you want to add a module inside another module, okay, if someone asks you, or if you are in a situation that can you add this module inside the app module, I want to use utilities module file or functionality inside our app module. So we can do that with the help of build.gradle-kts. We need to integrate here the path to the new module, and we can do that with the help of implementation project, and we can access from our modules.utilities. Now this statement is saying that I am integrating this sub project which we have created with the name of utilities. So whatever we will write here inside this module will be available to this app module as well. Okay, now we can sync the project. So far our project has turned into a modular application where we have this app module and utilities module. We have the central dependency management system with the help of build src. Okay, now inside our utilities module, we already have one utility function in mind that we are going to make API calls inside this project, and we want to make sure when we are initiating API call, we are sure that internet is there, right? So we can define one class, or let's say singleton class, okay, and we can call it core utility, okay, and inside this we can define a function. Now inside this function I am going to paste some code, and this is going to use context. So let's add this as a parameter. Okay, this code is going to tell us that if internet is present or not. This is showing some error because we have not added the network or internet permission. So let's add this, and this is going to be added inside the manifest of this utilities. Okay, we can also add another one for internet. Now did you notice we have two manifests as well, one for the app module, okay, and another one for our utilities module. And utilities is as of now just having this functionality to check internet, and this code needs the permission to access the internet and network state. So the permissions also we have added inside the manifest of utilities module. Now the next step is we will just open our main activity, because this is the launcher activity as of now. Inside this we need to set up the application screens. We can use composables, of course. So we can design one composable and we can call it news in short entry point. Okay, so we can call it like this, and this is going to be a composable. Inside this either we can design the screens here itself, or we can also use one navigation graph separately as a composable, and later on we can add that navigation graph composable here. Okay, but before that let's add few more dependencies, because we are going to use coroutines, we are going to use dependency injection with the help of Dagger HILT inside this application. So we will just go inside our dependencies file. So here we will add the dependency for HILT, and we also need to add the versions. So we will just add these versions as well. Now these error will be gone. We also need to add the plugins. So we will just close everything. We will go to the build.gradle.kts, And inside this we also need to add two plugins. Okay, so one plugin will be Kotlin KPT and the another one will be this com.google.dagger HILT Android. Now one more last step we need to do. We will just go to the product level build.gradle.kts, and here we will also add one class path plugin for our HILT dependency. Okay, so these are the steps we need to take in order to implement HILT inside our application. Now our HILT setup is ready and we can use HILT dependency inside our application module. So we can just use implementation and we can just take one dependency from our dependencies object, which is a singleton class object. We can just take HILT Android, and with the help of KAPT we can take dependencies dot HILT compiler and HILT Android compiler as well, and we can click on this sync now and our project will be synced. We can also add KAPT and correct error types equal to true. Okay, now we can finally sync the project and we can just use HILT inside our application. So this was the dependency part. If I just repeat for you what we have done so far, we have added HILT dependency inside our dependency singleton class object. These are the dependencies we have added. We have defined respective versions also. Then inside build.gradle.kts project level we have added this plugin. Okay, and inside our app level build.gradle.kts we have added this Kotlin KPT and HILT plugin, and we have added the dependency to use HILT. Okay, now we can utilize HILT inside our app module. So the first step in order to use HILT in any Android application will be we need to define one HILT application class. Okay, so we are going to define one application class and we are defining it inside our app module source directory, and inside our code we are going to define here one application class. To do that we can just use any class and we can call it news application. Okay, we can remove these comments and we are going to extend this with application class. Only one application class can be there inside a project, and this news application class is going to be our entry point. With this entry point, what do I mean? I will show you in a moment. Okay, so if you are new to Android, this application class is the first step which will execute when user will launch our application. Okay, inside this we need to override onCreate method. We are going to add one log statement just to show you. We need one tag. So to use a tag we are going to define one companion object and we can define one tag variable. And why I am defining this as a constant? Because this value is not going to change anytime, right? And this is a compile time constant, and we can use a static block which is defined using companion object. So we are going to define here one tag and then we can use this tag string inside our log. We can write coming inside onCreate. Now this is a simple application class, but as we are going to use dependency injection and we are using HILT, so we need to make sure that our application class knows that this is going to be a HILT project. Okay, so to do that we need to use one annotation HILT Android app, and this annotation we can only add inside our application class. We can take this and we need to add inside manifest. We need to add inside application tag here. We need to use name and we need to add our news application. Okay, this is the very first step, and now our HILT setup is ready. Our project is kind of a HILT application and we can use HILT anywhere inside any class from here onwards. So the moment we will launch our application, we will see that this onCreate method will execute. Let's launch it again. We can see the same log. So application is one very important class inside any Android application project. Let's minimize this and let's start further. Now we need to define the application navigation inside our main activity. Basically, all the screens we are going to have inside our project, we are going to define somewhere, right? Either we can define it here, but then it will be a messy code. So it's better that we define a separate composable, and from there we will just import the composable here. Okay, so let's define one app entry point. This is going to be one composable. Let's take this and let's define one composable with function app entry point, and inside this we can define one another composable which is going to have the actual implementation of navigation. Okay, so we can define app navigation graph. Okay, this is going to be one composable again, and for this we are going to define in one separate file. So let's open this UI folder once, and here define one new folder. Let's call it components. Now our UI package will be having this component folder, and inside this let's define one file and let's call it app components. And here we can define this composable which we was talking about, and we will call it app navigation graph. And we are going to import this inside our main activity. Okay, and inside main theme we can just use one surface with one modifier, and we are going to take the entire screen space. So we can do that with modifier.fill max size. We can also use one background color, and this is going to be a white color itself. Okay, let's take this in next line, and this app entry point we are going to place inside. So this is one very simple syntax. We have the theme opening scope here, then we are having just one surface composable. This is like we have one entire screen space contained here, and within that we are going to put our app entry point, which eventually is going to have the destination from our navigation graph, which we are going to define here. Now one more step we need to do to make sure that our activity is also respecting Dagger HILT rules. We need to annotate our activity with Android entry point. Okay, and this is one HILT annotation, and this is coming out of Dagger HILT Android, and this annotation we need to use in all of the Android components like Android activities, fragments, services, and so on. Now our compiler will understand that this main activity is also a part of HILT. Okay, and if any necessary HILT dependency will be needed further here, so compiler will be injecting those. Alright, so don't get confused, I will show you step by step, just stay with me. So now inside our app navigation graph we are going to implement the navigation. And to implement the navigation, as we are going to use HILT as well, we can use one dependency which is kind of HILT related navigation for Jetpack Compose. To do that, let's close all the other files first, and let's go to build src and in dependencies. Let's minimize this, and we are going to define one new dependency for HILT navigation compose. And we are going to add this dependency Android X HILT navigation compose. We are also going to define one version for this dependency inside our versions file. We can just take the same naming convention, and we can define one constant, and we are going to use version 1.0.0. We can use this inside our versions. So this is the new dependency we have defined, HILT navigation compose, with this dependency syntax and the respective version. We are going to use this inside build.gradle of app module. You can also find it inside app module here, build.gradle KTS. Alright, we need to add this dependency with implementation dependencies dot HILT navigation compose, and we can sync the project. Our project is synced. Now we have this app components inside UI components. We are also going to define one navigation package here. Let's call it navigation so that it can be separate, and inside this let's define one file again, and let's call it app navigation. And we are going to move this app navigation graph composable inside app navigation file. Inside app components, we are going to define few different composable which we are going to define shortly, but this navigation graph composable we are keeping inside navigation package. So all the navigation related things we are going to keep here. Alright, now we have added the dependency, so we can access this nav host. Alright, and inside this we need to add the nav controller and one graph or the starting destination. Okay, we can add one lambda here for the navigation graph building part, but before that let's create one variable nav controller, and we are going to use, remember, nav controller, this one. Now we can use this and add it here. For star destination we need to define some kind of routes, right? So either we can define something like this, that this home is going to be the entry point, but this is not safe, because if later on you change this string somewhere, you misplace this sparing, so this star destination will not match, right? So the best practice will be that we define one singleton class, we call it routes, and inside this we define one constant for home screen like this. Okay, let's take this and add here from routes dot home screen. Now you see that all the navigation related things we are keeping inside this package. It will be very easy as our project will grow, that we will be easily able to find all the things related to navigation here. Okay, now inside our nav host we are going to define one composable, and we are going to add the route for it, which is going to be the home screen as of now, and one lambda. Inside this we are going to define the home screen, but before that we need one home screen composable, right? So we can go back, and inside UI itself let's define one package, and inside this let's create one file, and we are going to call it home screen. We can just use one composable, we can call it home screen, and inside this we can just add one surface for now, and it is also going to take one entire screen space with modifier.fill max size, and we can add one preview, one composable function home screen preview. Inside this we can add our home screen itself. Okay, one error we have, because we need to import this again, because now we have defined this inside our navigation package here. Alright, let's go to main activity and let's check once again. We don't have any other unwanted annotation, we can remove that. Okay, now we have our home screen composable, so we can close this, close main activity and routes as well. And inside our navigation we are going to define the screen for this route home screen. Okay, so we can just use home screen composable, which we have just designed. Okay, so this means that if someone will come inside the navigation host and they will try to navigate to this route, which is home screen, so they will be shown with this home screen composable. Now inside this project we are also going to implement ViewModel repositories, because we are going to make some API calls to find out some news to show inside our application. Alright, so the next step is we are going to define one package for ViewModel and one package for the repository. Alright, and this is going to be the main part of MVVM, because inside MVVM we have one view, then we have one view model, and we are also going to have one repository which will be responsible to fetch data either from server or from our local database. Alright, so let's define one view model first, and let's call it news view model, and let's extend this with view model itself. And as we are also going to use HILT here, let's annotate it with HILT view model. So I have seen this comment in the videos that how we can define a view model. This is the normal step. Just define a class, extend it with view model, and you are done. Then you can keep all the logic here. We are also using dependency injection in this video. So we are using HILT for it, and we are annotating our view model with HILT view model. Why? Because if we want to inject it somewhere inside our composable, this HILT process will make it super easy. I add one init block, and inside this I add one log. So for that, first let's define one companion object also, and let's define one constant tag, and let's use it. I know that so many of you will think that why we are defining a companion object, just put here as a val tag and something like that, right? But that's not a good way. Just follow the practices when you are developing, and it will be super beneficial in the long run. And now we can use our tag, and we can call it init block of news view model. Okay, so I just want to show you that how easy it is with HILT to use ViewModel inside our Jetpack Compose application. To create a variable instance of this ViewModel inside our home screen, let's go to home screen first, and inside here we can just access it with the help of ViewModel. We have one variable name news ViewModel, and the ViewModel type it's news ViewModel, and we can initialize it with HILT ViewModel. Okay, and we can run the application. It will throw an error, but I want to show you that error as well. If we just check the details of this error, it is saying that @HILT ViewModel should contain at least one inject constructor. Okay, it's saying that if you are using @HILT ViewModel annotation, there should be at least one constructor to inject the dependency at the runtime. To solve this error, we need to use one constructor first, and we need to add the annotation inject. Okay, now we have one empty constructor. So as we are accessing this news view model inside our home screen, so compiler will be able to inject this news view model at the runtime. If we run our application, now that error will be solved and our application will launch smoothly. See, now we are not having that error and our application is launched. This means that HILT has injected one instance of news view model inside our composable, and the best way to make sure is we can check the log inside logcat, and if HILT injected one instance inside our home screen of this news view model, so this init block will be executed and we will be able to see this log inside the logcat. So if we just add this, we can see that init block of news view model. That means when HILT injected this view model inside our home screen, it was successful, and we are able to see that this init block has been executed. So now the next part is we are going to add one repository. So to do that, let's create one file and let's call it news repository. Okay, our news repository class is created. Here we need to fetch the data from some data source. So first of all, we need to find out one API from where we can fetch some kind of news response, and we are going to use this website newsapi.org, and it has few APIs which can give us some data. Like we have this API newsapi.org v2 everything. We can query a value and it will give us some articles which will have some author name, titles and URLs and description, so many things. We will find out this response, and then based on this we will create our composables. Now we can go to the documentation part, and here are some endpoints, everything, top headline and so many things. So if we just go to this top headline, so we can utilize these APIs. To do that, first of all we need to add retrofit dependency. So we'll just go inside this dependency part. Let's minimize this, and we can add some dependency which we are going to need in order to make API calls. We are going to use Retrofit to make network calls. We are going to also use OKHTTP, JSON and Moshi converters and login interceptor. Basically these are the things which will help us to see the API call URL endpoints with the parameters we pass and the respective response we get inside our logcat. We can also use Moshi or JSON converters. I will show you which one we use and how we use them. Let's define the versions as well. So we can add the versions, and if you are following along with me and you are coding, so you can just pause the video here. You can utilize these same versions from here, and if you want to use the dependencies, I will show once again. You can pause it here. You can just take these dependency and these versions. Alright, and now we can sync the project and we will be able to use the retrofit and these dependency inside our project. Okay, our project is synced. So now we are going to define the data layer of our application. As of now we have this UI layer. Let's take this main activity inside UI layer itself. Let's minimize this. Let's create one package, and this package is going to be the data layer package of our project. And inside our data layer we can create few sub packages, one for retrofit related APIs. So we can just create one API. Now we need to go to the finder to define few other packages. We can define one package entity, and this is going to have all the Pojo classes, right? So now we will be having these two packages here. We can define one package for data source. Okay, first of all we need what kind of data model we need to define for our response. So we can just try to hit this sample API, and once I hit this I am getting some response. We can paste that inside JSON where and format it. So we are having something like this. We have one JSON object, we have some status, we also have that how many results we are getting, we have one array articles. Inside this we have multiple object, and each object have response like this. We have some author, title, description and URL and so on. Okay, so let's start designing the data response. So inside the entity package we can define one class, and it can be a data class because this is going to contain some response, and we can call it news response. So we have one status. Alright, so let's take this key, use one status of string type. Next thing is we have one total result of integer type. We can define it of integer type. Okay, next thing we have one array of articles or one list we can say, and we can define it like this, list of article. Okay, and this article is going to be a data class again. So this article object has so many things: author, title, description, URL, etc. So let's take author first. Let's define author of string type. Next we have title of string type and some description of string type again. We also have URL and URL to image of string type, and we also have published at what day or date it has been published. We also have some content. I think this and description, no, these are the different things, so we can just take this as well. Now this article object also has a source object. If I show you inside viewer, this is our object. It also has an object called source. Okay, so we can use this. We can create one variable source, and let's say we define one class called source. Okay, and we can create one data class for this source, and it has ID and name, right? So we can just use one ID as a string and one name as string. Okay, our response is created. Now we need to create one API interface where we can put out the API endpoints, but before that we will need the new dependencies which we have recently added inside our build.gradle.kts. Okay, so if I minimize everything, this is the application module, this is the respective build.gradle file. Here we are going to add the dependency from our dependencies file of retrofit. Then we need the dependency for OK HTTP. Then we need for Moshi and Moshi converter, and one last for logging interceptor. Okay, then we can sync the project. We will see all of these things in action just in a moment. Now we can close this. We can come inside source, our data layer. Inside API we can create one interface and we can call it API service. Okay, inside this we can access all the endpoints. We can define functions for all the endpoints with get, post and so many other things. If I just show you, if we import retrofit HTTP, then we have so many annotation. If we have some get URL, we can use this. If we have post, we can use this. We also have for query, body and so many other things. So now let's go back to the API endpoints website. So this is going to be one sample URL. Let's paste it inside our interface. Okay, and we can define one function get news. Okay, and let's say get news headline or something, and inside this we can define some parameter. Now as we can see that country is one query which we want to pass inside this function, right? So we can write it with the help of query annotation. Okay, we can define the field name which we want to pass inside query, that is going to be this country. We can pass one parameter as country of string type inside this function. Okay, and we need to pass the API key as well. So let's add another one as a query and let's call it API key. We can also pass API key as a string, and this API key we will get from this website. We can add it as a default value. We just need to replace this. I will replace it, but I will not show the key here because anyone can misuse that key. So don't show your API keys to anyone else, as this is going to be a get URL. So we can just define get. We can import it. It will import from retrofit, and we can define this much URL as the base part, and we can take from here v2/top headlines. We can add it here. Okay, this function is going to return us one response, and this response is going to be that news response Pojo type which we have defined. Alright, now this function as of now is a normal function, but we are also going to utilize coroutines. Okay, so before we move towards coroutines, I just want to show you, because we are at the point where we are using this URL. So as of now we have just used a small part of it from where the initial part or the base URL will come from. Okay, so for that let's define one dependency injection layer and let's call it di. Okay, inside this we can define one file. It's going to be a normal file. Let's call it app module. Now we are going to annotate this from module, and this is coming out of Dagger. That means this is going to be a Dagger module, and we use modules to define the third party dependencies. Okay, and where we want these dependency, we want in entire application. So we want to make sure that all of the dependency we create inside this module should be accessible inside this entire project. So we can just use singleton component class. Okay, so this is the normal process in order to define a module for dependencies inside Dagger HILT. Okay, If you are not so sure about Dagger HILT, so comment down in the comment section that we need Dagger HILT tutorial as well. I will create one separate video for Dagger HILT series, okay, where I can explain you all about Dagger HILT and how we can utilize Dagger HILT in and out. Okay, so first of all we need one retrofit dependency, so we can define one function provides retrofit, okay, and this is going to return us one retrofit object. Let's import it, and we can return here one retrofit object. So to create one retrofit object we can use this retrofit dot builder, and retrofit use builder pattern. I have explained how we can define one builder pattern at our channel Native Mobile Bits. You will be seeing the builder pattern video also. If you want to check out, you can check this video. Now let's move forward. So to create one retrofit object we can just use this build method, okay, but this is the very simple retrofit object. We also need to add so many things here. So the first thing we want here is that if our application is making any API call, we should be able to see the logs inside logcat, that what is the endpoint our application is hitting, what is the status, what is the response we are getting, and so many other things. So we can define one HTTP login interceptor, okay, and this is going to be of type logging interceptor itself, one object, and we can use scope function apply, okay, and here we can define that what kind of logging interceptor label we want, and we have multiple labels, dot label dot basic body or header or none. If you choose none, you will not see any URLs or anything. If you want to choose body, so all of the details will be shown, and if you just want to see that endpoint and the status, you can choose basic. So we are going ahead with basic. Now we also need one HTTP client to associate with our retrofit. So we can take that from OK HTTP client dot new builder, and we can use a scope function again. Inside this HTTP client we want to add one interceptor, and that is going to be our logging interceptor. Alright, now our HTTP client is there, but if we want to add some kind of timeout inside our APIs, so we can do that with the help of, we can use here read timeout. We can provide some kind of duration for timeout, and we can provide some kind of unit seconds. This means that all the API calls our retrofit with our HTTP client will make will time out after 60 seconds. Okay, we can also create one Moshi object with the help of Moshi.builder. We can also add one Kotlin JSON adapter factory here for all the Moshi related conversion, and we can use build. Okay, so these are few things which we are going to take inside our retrofit object, our final retrofit object. So we are going to customize it now. We are going to add one base URL first. So from where our base URL will come, as this is going to be a app level thing, we can define inside data one singleton class, and we can call it app constants. Inside this we can define one constant app base URL. Our base URL we can take from our service, as this is going to be the base URL. Okay, so from v2 top headline we have defined the path here, then we have defined these things as query, and the first remaining part, this much, we are going to define as the base URL. Now we are going to use this when we create the retrofit object app constants dot app base URL. Alright, now we need one client, so we are going to use our HTTP client dot build. It will give us one client object. Now we are also going to add one converter factory with add converter factory, and we can just use Moshi converter factory dot create, and we can pass the Moshi object which we have created over here. Alright, now this is going to provide us one final retrofit object, and we can just use here the provide annotations, and singleton annotation as well. This means we have created one dependency, one retrofit object, and we can use this anywhere inside our application, and Dagger HILT will inject this object. After doing all of this work, we no need to write this logic everywhere, and this is going to be a decoupled code. It's not tightly coupled at all. It's very loosely created at a separate place, and this is following dependency injection protocol, and we can just inject it anywhere we need. Alright, now let's minimize this. Now we have retrofit. Now as we are defining some dependency here inside our app module, we also will be needing this API service as a dependency at some point of time inside our repository, from where we will be calling these functions, right? So we can create one dependency object for this API service as well, and to do that we need to define one function. Let's say provides API service. This function will take retrofit as a object, and as we have already defined retrofit dependency, we will be able to get it, and this function will return API service, which is this, right? Now inside this function we can use return, and we already have the retrofit here, so we can just use create. We can pass API service class .java, and this will return one API service dependency. We just need to use singleton and then provides annotation of Dagger HILT. Okay, now we can use retrofit object anywhere. We also have the API service dependency we can use anywhere. The next thing is we need some kind of data source. So let's close this. We need one data source for this. So inside our data source we can create one interface, and let's call it news data source. Okay, inside this we are going to define one function. So we can just take this. This is the quickest way. We can remove these queries and all. We don't need to pass API key because we will add the default value inside our interface here. Okay, so we just need to pass one country and we will get the response. Alright, we can remove this. Now we need to provide the implementation for this data source. So to provide the implementation, we can create one class and we can call it news data source implementation. Okay, this class is going to implement news data source interface, and the moment we implement this, we are going to take this overrided method. Let's remove this. Now inside the implementation we need to call this API service method somehow. For that we need the reference for this API service, right? So basically we are saying we need this API service object inside our news data source implementation class, and that's why we have created inside app module one dependency provider for our API service, right? So we can use one inject method with the help of constructor inside this class like this, and we can write constructor. We can just import this inject statement, and inside constructor we can just use private variable API service like this. And now whenever we will create this class instance, Dagger HILT will provide us one API service object, which we can use inside this function like this, return API service dot get news headline. We can just pass the country like this. Okay, so you see what we are doing here. We have one API service where we have the method which provide us some response. We created one data source implementation with the respective data source of that function. Okay, inside the data source implementation we are injecting API service dependency, and we are calling the respective function inside this interface API service. Alright, now let's close all of these things. And one thing I want to do here is Right now these functions are normal. These are not suspended function, right? Because we are not using coroutine anywhere. Let's go to dependencies, and here we will add the coroutines dependency. So I have these two dependencies, coroutine core and coroutine android. You can pause if you are coding with me, and you can just write down these dependency, and we are going to define one coroutines version, and we are going to use the same version for both of these core and android related dependency. Let's sync the project, and now we will be able to use coroutine related code as well. And one more thing, if you are not familiar how to use coroutines, what are coroutine, why we should use them, and so many things related to coroutines, just comment down in the comment section that you want me to cover coroutines as well separately. Although I have it in my plans, in my future plans, but just I want to hear from you that how many of you are new to coroutines. Alright, now let's close the dependencies file. Now we can just go to the build.gradle file of app module, and we can just add the dependencies which we want to use. We want to use coroutines dependency, core as well, and coroutine android as well. Now finally we can sync the project, and we will be able to use coroutine dependency inside our app module, which is this. Right? Let's close this file, and now we can make this function as suspended function. Alright, and this get news headline will be a suspended call to the network. Now if we will go to the data source, we will have suspended added here as well. If we go to the news source implementation, news data source implementation, we will see one error because this is not suspended as of now. Now that error will be gone. Now let's close all of these things. Now let's open the news repository, which is inside app source main, and inside UI repository news repository. Okay, so basically our repository needs this data source, right? This one, so that we can call this function. So first of all, we need to add this as a dependency inside our app module. Let's come here, let's minimize everything. This is a module for Dagger HILT where we are writing all the dependency related code. So we are going to write provides, then singleton, and we are going to write provides news data source. So if we want this news data source, we have the implementation, right, which provides us one news data source. But for this implementation, we need API service, right? So this API service as a dependency we already provides. So we can add here API service, and it will return news. Let's minimize this first. News data source. Alright, and here we can use return, and we can just call news data source implementation, and we can pass API service. Okay, and this will provide us one news data source which we can inject now inside our repository. So first thing, we need to use inject annotation, then we need to use constructor, and inside constructor we are going to have the data source, which is news data source. And from where Dagger HILT will inject this? From here, where we have created the dependency. Alright. Now inside our repository class, we can define one suspend function based on our data source. Okay. So we have one headline function. It will take country as a string as a parameter. Alright. And it will return us response of news response. Okay, this is defined inside data source as well. Alright, so now here what we will do, we will just use return a statement, and we will return the response from our data source dot get news headline. We will just pass country, and we will fetch the response from this data source. we will return, which is the same return statement for this function. Now I want to make this function more enhanced. We want to enhance this function even further. Why? Because when you make one network call, you have three possible different states. One, when you are making a request, at that time you are having some kind of loading inside your application, you can show some kind of loader or something. That's one state. Another state is when you have successfully fetched the data, so that is a success state with respective data response. The third state can be one error state where you fetched some kind of data from server but you was not successful, you ran into any error, and we will also provide that what kind of error we are getting, right, so that we can update our screens composables accordingly. So to define a mechanism where we have these three possible state, only maximum three, we have something called sealed classes. So to do that, let's go to our utilities package. This is basically one utilities module, and inside our main class we can define here one sealed class, and let's call it resource state. Okay, this is going to be one sealed class. So the first step is going to be loading. Okay, and this is going to be of type resource state generic. And the next, now second state can be a data class success, and we can hold generic data type, and it is going to have some kind of data, let's say of generic type again, and this will also extend, or it will also be of type of resource state. Alright, now the third one can be one error class. We are defining it as a data class again because we can also provide some kind of error of type generic, like it can be a string error or integer error code or something. Again it will be of resource state T. Okay, this is one very basic sealed class which we have defined. If you are not sure what is a sealed class, we have one separate video for sealed class implementation, and you will be seeing on the screen right now. You can check out this video as well. So now as we have our resource state with three different states, we can modify this function. Alright, so let's create one same function. Let's comment it first. So now we are going to take this first part of this function. This is going to be same, but we are going to enhance it with few other things. We are going to use flow. Alright, and we are going to pass a flow of resource state. By default it's going to have news response. Alright, now we are going to return one flow, and inside this flow builder let's write based on different conditions. Okay, so first of all, whenever this function will be called, initially we will emit one resource state of loading. To make an API call, we will emit loading state. We will say that okay, we are making this API call, but right now the state is loading. Okay, then we will fetch the response from data source like this. We are going to take this in one variable and we are going to call it response. Now here retrofit is going to help us. We can add one check that if response is successful, this is successful will return true if the API call is success, else false. This is coming out of retrofit library itself. And we are also going to add one more check that if response body is not null. Okay, so we can just add like this. If it's not null, that means we are having a successful message from the retrofit library that your API is successful, and we are also having some response, like we are not getting a null response or something. Then we can emit resource state dot success, and we can pass response dot body. And as this is not going to be null because we have added this check just here, we can make it like this. Now we are saying that we are sure that body is not null because we have already checked it that body is not equal to null. Now if this condition fails, that means if Retrofit tells us that your API call is not successful or we are getting null response, we can emit error state. Okay, we can use resource state dot error and we can pass here some manual message that error fetching news data. Okay, we are having one error here because this resource state error, we have defined it as generic, but let's make it any, that we can pass any type of value inside error. Okay, but as we are just passing as a string, we can also make it one string type. Alright, now it's fine. We have one error state handled as well. So this is our flow statement. We can also add one catch block here. Okay, and we can use this as one exception, that if we are getting any exception inside our flow, we can emit one error state again based on this localized message. If we are getting anything else, we can pass some error string. We can just say some error in flow. Okay, and that's it. Okay, so this is going to be our function. Here we are just checking based on some conditions that if we want to make sure that we are having success state or error or loading state. Alright, now let's close all of these things. Let's go to our view model. Now inside our view model, we need to call this function to get the response or error or loading state. So we need to call this function, and to call this function we need repository access, right? We need here the repository. So let's add one dependency provider inside our app module for the repository. We can call it provides singleton dependency only, and we can call it provides news, or let's take it from there, provides news repository, and this repository will return us news repository object. Now if we go to the repository once, we need data source, so we can add this as a dependency inside this method, and we can return news repository and we can pass news data source because we needed the data source here to call this function even further, right? Now inside our view model, we can access news repository like this, and HILT will inject this at the runtime. Okay, so we can remove these things, we don't need it anymore. Now inside our news view model, we can define one function get news. Alright, and inside this function we can call the function from our news repository, this one, but it will throw us one error because this get news headline is a suspended function, and we can call one suspended function only from a coroutine. Okay, so we need to do here some changes. First of all, we need to use ViewModel scope, and we need to use one coroutine builder which is launch. Alright, now if we want to make sure that our API call runs on the background thread, we can use dispatchers. These are a part of coroutine itself, and we can choose all of these threads with the help of dispatcher. We are going to choose IU thread, and this will make sure that all of the API call operation happens on the IU thread, which is going to be a background thread. And that's a good thing, because if you have seen my previous video where I was talking about asynchronous programming, we always want to make sure that our application's main thread is not doing so much of work. So now we can call the function from our repository get news headline. This function need country as a parameter, so we can add one parameter here as well, country string, and we can pass it here. Okay, and as this function is returning a flow, we can collect this, and to collect a flow we can use collect latest. And this collect latest function is a extension function of flow, and this will give us the response, basically the flow which we are getting out of this function. Alright, so we can define here news response. Okay, and we can define one mutable state flow and a state flow which we will use inside our composable screens. You will understand in a minute. So let's define one private variable news, and this is going to be a mutable state flow, and the flow type will be exactly same like resource state of news response. Okay, so we can use it here, and we can initialize it with one initial loading state. Okay, so we can pass it here resource state dot loading like this. So this is one mutable state flow. Now we want to expose one flow to our screens also, so we can use one state flow, and the type will be same resource state of news response, and we can assign it with news. So now you must be wondering that why we are having these two variables. So if you notice it carefully, this underscore news is a mutable state flow. Okay, so we can assign the value to this inside our ViewModel itself. Alright, now when we are passing this news to our UI, we want to make sure that UI cannot change the value, right? So state flow cannot be changed. That's why we are exposing it to the UI. And here we can change the value of our news mutable state flow with news response. Okay, so in this function we are just opening one ViewModel scope on the background IO thread. We are calling the method from our retrofit. We are collecting the latest response, news response, and we are assigning it inside our mutable state flow. And once this value will change, automatically it will be assigned inside our news state flow. We can use this inside our UI now. One more thing, we want to make sure that whenever this view model is getting created, let's call this function. Okay, so let's add init block here, and let's call get news. We can do one more thing for now. Inside our app constants, we can define one country, and let's use US for now, and we want to make sure we are passing this country inside get news function. So we will get some news for this country which we have defined it here. Okay, so let's make it private for now because we are just calling it from init block. Now let's try to close all the tabs. We can just go to the home screen. So as we already have news view model instance here, we can create one variable news response, and we can access it from news view model news, and we can use this extension function collect as state. Okay, so whenever this news will change, we will be having the updated value inside our composable because we are collecting it as a state. And if you are not familiar how to work with state in Jetpack Compose, I have covered it in various videos on our YouTube channel. You can check out these videos and you will understand how to handle the state in Jetpack Compose. Alright, now we have the updated response here. I am just trying to show you that are we getting the API response? Can we show that? Then we will make this app beautiful. Now inside the surface composable, we are going to add one when expression, and this is going to take our news response. Okay, and inside this we are going to handle all of the possible resource state. Why? Because we are accessing this news and this is a resource state. This resource state has three different states. We are going to handle all of these. So inside our when expression, first state we are going to handle from our resource state loading. Okay, and we are going to do something here. Then the second one, if resource state is success, then the last one, if resource state is having some kind of error. Whatever our resource state will be there, it will update and we will get callbacks here accordingly. Because we are collecting this as a state, so whenever anything will change inside this, our state will update and our composable will compose here. Based on that respective state, we will show something inside our screen. So let's say if we are coming in any of these states, first of all, I want to add one log. Okay, we have some tag. As of now, I think we don't have. So we can define here, let's say tag, and let's call it HomeScreen. Okay, now we can use this tag and inside loading, let's add it here, success, and this one inside error. Alright, now let's close other files. Let's open our app components file, and this file is present inside this components. Let's create here one composable. Okay, and let's name it loader. Okay, now inside this we can use circular progress indicator. We can customize it. Let's give some custom size, let's say 50 dp for now. We can customize it little bit more. Let's add one padding 10 dp, and let's add some color as well. For now, let's try to use color dot black. Okay, now we can take this component, and whenever our loading state is showing up, let's add this loader composable. So now let's try to run the application once, and let's see if we are getting this loader or any of these logs, right? So we can see that we are coming inside loading and inside success as well. That's why we are not able to see the loader as of now. So we can comment the success state for now just to see the loader part and customize it even further. To do that, let's go to news, comment out this. So we can see our loader is showing up, but this is not how we want our loader to look like. We want it here in the center, right? So let's use one column composable. Okay, and let's put it inside column. So now our circular progress indicator is inside one column composable. Now we can customize our column composable with modifier, and our modifier is going to take max size. Then we are going to add some kind of padding as well here as well, 8 dp. Okay, now we are going to align it, so horizontal alignment with alignment center horizontally. We also want some kind of vertical arrangement because we want it in exact center, so we can use arrangement dot center. Okay, and now if we try to run this, it should come up in the center. Yes, so our preview is updated and we can see that our loader is in center. Let's modify this little bit, 60 dp. Yeah, now it's fine. And let's use one color from our theme color which we already got when we created our project. So first of all, let's import this, and we need this purple 40. Now we can use this purple 40 color directly. Okay, so we can see that our loader color is purple now. So at least our loader component is designed now. Now we can use this inside our home screen. So as we are already using it inside our home screen, now let's move to the success state. Let's minimize it little bit. Inside success, let's use response variable, and we are going to take this news response as, we are going to typecast this as response success. Okay, we can also take it inside a bracket like this, and we can just take data. Okay, so now let's try to access something from this response. Let's take this log here below it, and let's see how many items we are getting inside the data, right? So we have these total results. So if our API is giving us some response, we will have some kind of value inside this total result variable. Okay. So if you just see, we have this model, right? If we get some data, we have some total result. Also, let's add response dot status. This is fine. Now let's try to run the application once again. Let's see if we are getting some kind of data here. So if we just add this home screen here, so we are just getting loading continuously. Why? Because we have not uncommented this. Okay, now we are coming inside this success block and we are getting status as OK and total result is 36. So let's try to see that what URL we were hitting. So this is the URL we were hitting, and if we just try to hit it, how many items we are getting? We are getting total result as 36. So our API is getting called successfully and we are getting result correctly. Now we can also add one check inside our error state. We can just take error and we can cast this news response as resource state dot error. We can take it inside one bracket and this is going to be a string. Okay, so we can just take this log down and inside log we can print the error message, this one. Okay, and as this is a string, no need to use curly braces as well. Now our basic setup is ready. It's very basic, I know, but for now let's try to see the list of the data which we are getting. Okay, so we can just add another composable and we can use that inside app components as well. Okay, let's minimize this composable. Let's create another one, news list. So now we are going to call this news list from our success block. Let's call this and let's pass some data. Let's pass response. Okay, let's add it as a parameter. Now here we can use one very basic LazyColumn for now. Let's remove these things. Inside this we can use items. We can add response dot articles and one lambda block. We can use it, this one. Okay, now inside this we can show some kind of text. So let's say we just want to create one composable, normal text component. Okay, and inside this we can use one text composable from Jetpack Compose. Text value we can pass as a string. We can use it here. Okay, and we can modify this text little bit with modifier. So we can just take modifier dot fill max width so that we can take the entire space horizontally. Then we can set some kind of padding, let's say 8 dp on all sides. Okay, and for height part, let's add wrap content height. Okay, this is one very basic text which we can have. We can also add some kind of a style with text style. Inside this we can pass font size, let's say default 18 sp, and font weight and let's say normal. For now this is the text component which we want to show inside our list, and for every article we will get one callback inside this lambda. So from article we can access title. If it's not null, else we will show not available. This is the response. We are getting a list of articles. Every article has a title. For now we are just showing that. Let's try to run the application. So we are getting some data. Okay, Yes, I know this is very basic, but at least our repository, ViewModel, HILT dependency, everything is working fine. We are getting the data from the network via our data source, repository and ViewModel to our composable screen. Now we are going to make it beautiful with the help of Jetpack Compose. So the first thing I want to do here is I want to show some kind of news icon when our app is loading. And for that we need to add splash screen dependency inside our build src dependencies. If I close everything, this file is inside build src dependencies. So we are going to use this core splash screen dependency. We are going to define one version for it. This is going to be the version which we are going to use. You can pause and take this version as well. You can take this dependency as well if you are coding along. Let's close this, and now inside our app build.gradle.kts we are going to use splash screen dependency. Okay, let's sync the project. So we can just go to our main activity as the next step, and before set content we can use install splash screen. So for our app logo we are going to use our channel logo itself. Okay, now we need to define one theme. Why? Because if you just go to Android manifest, we have some predefined themes which is used in application and activity. Okay, so now what we need to do is we need to define one theme for our splash screen. Its parent is going to be theme.splash_screen. Inside this we can define few items, that what kind of splash screen background we want. So we need white color. Then we can define that what logo we want to see inside our splash screen. So we can use logo, which is going to be our channel logo itself. And we can say that after our splash is done, what theme which we want to show after splash screen. So that is going to be style theme.news in short, which is our default theme. Okay, now we can just use this splash screen theme as the starting theme inside our application tag and activity, and that's it. That's the thing which we need to do in order to set up our custom splash screen. So if we run the application, we will see that our logo will be shown at the splash screen. Okay, now it's looking much better, right? If we kill the application, we launch it again, we will see our logo and then our application will start. We can change this launcher as well. Let's try to see if our logo will fulfill this. If we run the application now, let's see if our logo is changed. Yes, we can see that we have our channel logo here. It's not coming in the entire space, but it's fine for now. So now let's go back to our main activity and let's update the UI of our application. So as of now, our main activity has the app entry point inside one surface. Okay, so inside our app entry point we have the basic navigation setup ready. Inside navigation graph we have this destination for home screen where we are showing the home screen. Okay, if we go inside this, here again we have the surface. So we need to modify it here. What we are going to do now, inside our home screen we are going to use vertical pager. Let's minimize this, and inside our vertical pager we need the state. So let's define one variable pager state, and we are going to use remember pager state. Okay, and this API is kind of experimental as of now, so let's opt in for experimental foundation API. It will come into stable APIs in future, and this remember pager state is going to take these two things, initial page and initial page offset fraction. So we can define initial page as 0 and initial page offset fraction as 0 in float. Okay, and let's use one lambda here, and let's define item count, let's say 100. We are going to change it. We are also going to implement pagination in future part of this video series, but for now let's define 100. Now for our vertical pager, let's use this state we have created as pager state. Now we are also going to customize it. Let's use one modifier, and let's take fill max size so that it can take the entire space of the screen. We can also define various other things. We can define some padding, page size, page spacing, and so many other things, right? So let's define page size, and we can use page size dot fill, this one, and let's use some kind of page spacing, and let's use 8 dp. Let's import this. This is basically if we scroll the page up, how much space there should be in between of these two pages. I will show you this. Okay, and we are going to take here one page. This is going to be one integer type, of course, like at what page number we are at any given point of time. Now inside this we can take all the things which we were having. Okay, we can remove this surface. We don't need it anymore because we are already having surface in the parent screens. Okay, so inside vertical pager, what we are doing, we are having these three states. Alright, as of now we are not using this page, but let's add it inside this composable news list. So now basically we also need to remove this composable because we are not showing normal list, we are showing this pager. We can create one new composable news row component. Okay, and this component, this composable, is going to have two things. One, page number, that at which page number we are at. Then it is taking response dot articles dot get the value at that page number, so that if we are at 0th page, we are going to take the first article value. Okay, but we can add one safety check here, that if response dot articles is not empty, that at least one article is present, then only show this news row component. So we can just go to our app components, and we can define here one composable news row component. It is going to take one integer page, and it is going to take one article. Okay, so this response dot articles will give us one article object, and then we are already having this page from our vertical pager. Okay, now we can import this. Alright, so we are having this home screen where we have this view model which is giving us news response. We have created one pager state. We are having our vertical pager, and we are handling all of these states. Once we come inside success, we are just showing news row component based on the response we are getting. Okay, so now let's go inside this news row component and let's modify it. So for now, if we just use our normal text component, so let's try to see this page number. So let's add some more string from article dot title. This we can take in some new lines. Now let's try to see this, how our application will look with this vertical pager. So our application is running. We are having first news, then we scroll up, we are having the second news, we scroll up again, we scroll up again, we can also go back, right? Like this we are having our news. That means our vertical pager implementation is also working fine. Now let's modify this news row component. Okay, so first thing is we need one image library to show images from these URLs. So we can try to use Coil Library. We can just go to the dependencies and we can add this Coil Library. We can go to the versions and we can add Coil Library version. Okay, we have added this library. You can pause the video and you can take this. If you are coding along, you can also take the version. We can go to build.gradle of the app module. Don't get confused, this is of our app module. Okay, and we have added dependency inside this. Alright, let's close other tabs and here we can use implementation dependencies dot coil library. Okay, we can sync the project, and inside Android manifest, one weird thing, I have not added the internet permission. Still our API calls are working fine. Let's add the internet permission. Maybe I have added but later on removed. That's why from cache or somewhere it's working fine. But we need these two permissions, internet and network state. Okay. Now we have added this coil library as well. Let's close this and let's go to our home screen and let's go to news row component. We are going to modify it with one column composable because we are going to take so many things in vertical orientation. Let's create one preview, one composable preview for our function news row component, and we can add news row component here. Now we can just say, let's say 0th for page, and for article we can create one article object, one dummy article, and we can pass few things for our article. Let's say author, we can pass Mr. X. For title we can pass hello dummy news article. Okay, and do we need to pass any other things? All of these things are nullable, so we can just pass null to all of these things. We also have one way that in data class itself we can assign the default value as null there. We can do that, but for now I just want to add one dummy article here, so we are just passing it like this. Now let's try to modify our column further. So we are going to use one modifier. We are going to use fill max size because we are going to take the entire space, and we are going to add some padding. Let's say 8 dp for now. We can modify it later. We are going to use one background, and let's say white color. This is pretty straightforward as of now. So now we can add one image, and for model we can access this URL to image. Okay, so we can access article dot URL to image, and for content description we can just pass empty or null. So we can see that one image is updating, but let's try to modify this little bit with modifier. We can take the full width, so we can use fill max width. Okay, for height we can just give wrap content height as of now, and we can also add some kind of crop, and that we can use with content scale dot crop. It is extending, and as we are giving content height as wrap, so it is taking entire space. That's not correct way. So we can use one custom height here, and we can say 240 dp. See, now it's perfect. Now it's fine because this entire screen is dedicated for one news article at a time. So we can use it like this. Then we can use basically different content scale. Fill bounds is better actually, or fit is also nice. We can use any one of these. Also I have one placeholder image which I am just adding, and this is kind of like this, right? So we can add a placeholder inside this async image. This is coming out of Coil Library, which we have just added. So we can add one placeholder, and for this we need one painter resource. We need to pass the ID for the image. So that is going to be r dot driver dot our image. We need to import this r first, and that is going to be the placeholder image, this one. And if we ran into some error while showing up or downloading the image, we can show error image as well with painter resource. We can use the same image ID. Okay, now if we try to run this, we will see some kind of image, placeholder image, before our image actually shows up. So we are going to go ahead with crop. Let's see, crop is little bit better. And if I try to run the application, now you will see that some kind of placeholder image will show up before our actual image loading. So if we scroll up, we can see that one new image is showing up every time. Okay, that means one new article is loading up, right? Now we can add another value for our title, right? So our image part is done. Now we can add some kind of space in between. Let's say dot size 20 dp. We are adding some kind of a space. Then we can add our normal text component, and we can just pass some article dot title. If it's not null, else we can just keep it empty. So if we see the application now, it's coming up, but let's try to highlight the title. So we can just come here, we can create another composable. Okay, we can say heading text component. It is going to take text value again. Okay, so we are going to take the same text, but we are going to modify the style. We could also pass the value here itself, but I want to show you little bit simpler, so we are not complicating it. Okay, so we can just pass the font size as 24 sp, and we can make it as medium. So let's try to use this for our heading part of it. So it should update. If we run the application now, it should update. Okay, so it's updating. If we change something here, let's say let's make it bold, so it's updating, but medium looks fine. Okay, so we have added the title. Let's add some space below this title. This time we are going to add, let's say 10 dp. Okay, we can also do this with height, but I just prefer size inside spacer. Then we can add normal text component, and we can pass article dot content, or we also have description. So let's try to go ahead with content first. If it's null, don't show anything. Okay, so it's having some smaller content. I think in API itself we have it like this. So if we just try to see the description, but this dot dot dot, and for content this plus 2925 character, is it coming from server? Let's check it. So we have this description. Yes, we have this dot 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 here. Somewhere it's fine, but at few places it's coming like this as well. And for content, yes, we have this plus 3888 characters, and it's coming from server. So our application is working fine. It's fine. So we can add two normal text component, and let's try to show both of these things. Or I think it's almost similar. So what we can do is we can just use one of these description we can use. Let's increase the size of it. What do you think? Should we increase the size? Let's try to see some other font families in practice. So we can use sans serif, this one. We can use this one. Okay, this looks nice. So we can use this more space, but we can try to change the color. Okay, so let's say we have something in blue. Yes, but let's try to use one purple color from our theme. So we can just use purple 40, and this is looking much better. If I zoom it, our screen is looking nicer now. Okay, so this is our normal text component. Now below this, let's add what other data do we have. So inside our article we have author, we have some source. Let's do one thing. For author, we are going to define one new text component or one new component where we will show multiple values together. So let's minimize everything for now. We are going to take these things below row composable. Let's minimize this. We are going to take the preview below our component. Okay, so now I am going to define one composable for author details component. Author details component, and inside this we are going to take one row composable. Okay, we are going to use modifier with fill max width because we are going to take entire screen width, and inside this let's use normal text component, or let's try to use normal text component itself. Let's try to use one author name if it's present. Okay, initially, and by default this value is going to be empty if it's not provided. And we are also going to take author source, or simply we can call it source name. This is going to be string by default, empty value as empty string. Okay, and we can put it here. So let's say author name and source name. We can use this inside our news row component. So we are going to remove this, and inside this we are going to pass article dot author if it's present or not. Let's make it nullable itself if the values are not there, and let's remove the default values. We can just do it like this, that if author name is not equal to something like this with also, then we are going to show this. We can just access with it. Same way we can access for source name. We can pass here it. Okay, now we can just pass article dot source. If it's not null, then it's name. Okay, and if we are passing author details component, we will see one block inside one row. We will see the author name and the source name. So for this, only author name is present. Okay, one another thing to note here is our normal text component is taking full max width. That's why it's not able to show that to text. So let's replace this with normal text composable for now, and we can just change it to text. Okay, for this as well, and in between we can just add one spacer, and let's call it modifier dot weight 1 float, so that empty space will be equally divided in between. And let's go to the wrong import, delete it, and it should be fine. Now if we run the application, we can see both of these details are present. We can add some kind of padding in start and end, so we can just say horizontal padding, or we can say start, let's say 10 dp, and end 10 dp. Okay, so some empty space will be provided like this. Another thing we can do is, if we want to put this author block at the very bottom, right? So we can just come here, and instead of this we can just add here one weight. We can just try to see how it will looks like, and we can add one float. So it's coming at the very bottom. If we scroll, we have it here. Okay, and the space which I was mentioning, right, you can see the difference between this author detail component and the next page. If we increase that, where we can increase inside our home screen, if we increase that inside our vertical pager, let's say 80 dp. So if we will scroll, you will see more space. See, between the next image and the author component, you can see there is more space between the image and author component. So let's make it 8 dp itself, it's fine. And this name and other things, we can just give some kind of padding. Okay, so inside this, let's add some kind of padding from bottom, let's say 24 dp, so some space will be there. So that's it. Now this is our home screen, and inside our home screen we have this vertical pager. Inside success state we have this news row component, where we are having one column composable, one image, then some space, then some heading text, some space, some description, and some author details component, where we are showing author name and source name if it's available. Okay, so let me show you how our application is looking like. Let's kill the application. So if we launch the application, we have one splash screen, then we have our news application ready. We are fetching the data from the network, and we are showing the news, right? If we don't have the proper URL for image from our server, we are not able to show the image. We are showing a placeholder. Okay, we can go back, we can go forward. We are able to show the news properly. Okay, now few more things we need to do here. We need to handle the empty state. So I have one SVG with me, so we can just create one vector, this one, no data. Okay, so we have this image, we can try to use this. So when we come inside our home screen, let's say if our articles are empty, we are getting success state, but our articles are empty. So we can handle, we can show one empty space. So for that, we need to define one composable, and let's call it empty state component. We can use one column, and we are going to take the entire screen space here as well. So we can use fill max size, and we can use some kind of padding here, let's say 16 dp. Inside this, we can use one image composable, and we can use one painter resource. We can pass the image ID with no data, this one. And for content description, we can add one string that no news as of now, please check in some time. Okay, like this. We can add one image, we can add one preview. For this, we can add as a composable preview. We can just use empty state component preview, inside we can use empty state component. I think this is not going to build anytime soon. Let's use in code itself. Okay, so next thing we are going to do, we are just going to use heading text component, and we are going to add, and this actually we are going to make it null, and we are going to pass this inside heading text component. Okay, and we can extract this as a string if we want. Alright, so this is going to be added here, and now we can use this empty state component inside else condition if there is no article. Alright, so now let's try to run this, and I will make some change so that API call will give us empty response. This time we will get empty response. Let's see what our application shows us. Okay, at least we are seeing the empty space, but this should be in mid, right? So we can use some alignment here, and let's call it alignment center horizontally, and we can use vertical arrangement as well, arrangement dot center. Okay, now we want to also take this in center horizontally. We are using this component in other places as well, so we don't want to change this completely. Okay, so from our empty state component, let's pass some value to this. Let's call in center, or we can call it center aligned. That do we need to put this text in center aligned way? If we are passing true, then only we will do something. Okay, let's make it as a boolean parameter. Default value is false. So we are going to use text aligned, and if it's center aligned, then we need to use text align dot center, else text align dot start itself. Now let's run the application. It should be in the center. Okay, so now it's fine. So now if we revert the API code back, now we'll be having the data. So we'll be having the proper news state. Okay, we are having the proper news state, and if we don't have the data, we are going to have this state where we have this no news as of now. So that's it friends, that's it for today's video. I hope you enjoy this video. I have implemented so many things, including coroutines, Dagger HILT, MVVM approach, ViewModel, repository, including our data layers, UI layer, dependency injection layer, so many things we have done. If you enjoy this video, please subscribe to my channel, and please share this video with your friends who are learning Android. I will see you very soon with another interesting video. Please subscribe the channel and be happy.